Swayam Prabha. Digital India. Educated India.
So now think about only entropy. So in a node, we'll calculate the entropy. When we have n number in a node, we have n samples and we can calculate entropy for a node. Now you break that node into the 3 subnodes and you push all the samples in that subnode of the trees. And then you can calculate the entropy of these subnodes. And now you know what is the average entropy of your subnodes. Right? And if this average, what is the difference between this average entropy of your subnode and the actual entropy your parent node is your information gain. So that how much impurity on average you reduce. That is the information gain. So you have to choose a feature which is going to give you the maximum information gain. So it maximally reduce the impurity in the samples. Clear? So again, this is for our M1 region, and these are the number of Y's we have, and this is the definition of the entropy for the parent nodes. Now if you divided this parent node according to the A attributes, and you get some other regions. So here it was how to calculate. If you have the B, the children of the M. So for each B in the children of the M, you calculate the HDB. Your data set has also been divided. At some part has gone to the B node, and you calculate the entropy at B. And then this is the fraction, how to get the weighted average of your nodes. This is the entropy, average entropy of the children. And then the IG, the information gain of D with respect to this feature, this attributes A is going to be the parent entropy minus the students, the children's entropy. So this calculation I have shown only for the entropy, information gain, but similarly you can do it using any other impurity measure like classification error or the Gini index. So the example with the, you remember that picture photo was having some Gini. So we have done that on the Gini index. Now which one is better? So again you have to think about like so they have their own advantages and disadvantages. So when your samples are more like not uniformly distributed, then Gini sometimes helps, and when it is more uniformly distributed, then this biasness, if you have the class biasness, then maybe the Gini will be more helpful. So now we'll see one example. Now I want to know whether you know what to decision tree. Now it is clear what is decision tree, how to classify something a test data point using a decision tree, how to build a decision tree. So we'll see one example of that same sample. So here now how to do it? Can you tell me if when you have this thing and we are doing this tree, and how to do it? So now you have to take, when you have to put, it's at the root, no divisions are made. How it has selected this outlook is going to be the first break. It has a highest gain. So how to find out highest gain? You have to calculate gain for all 4 attributes. Then only you will be knowing that which is highest gain. So here, actually the parent entropy was this much. So it has only 2 classes. So it is the 9 by 14. I think 9 has yes and 5 has no. So 9 by 14 into log 2 of 9 by 14 minus 5 by 14 into log 2 of 5 by 14. This is the entropy formulations, and which is the entropy of the parent is 0.94. Now we are calculating the entropy of the information gain of the outlook. So here also, so why this 2 came? Because if you see that when you divide it in the outlook, both the sunny and the rainy has similar kind of divisions. So that's why I calculate it one time and multiply. So these are the entropies for these two subnodes, and this is the entropy for these subnodes, these divisions. But this division entropy is 0 because it has a 4 and one class is 0. So why it is 0 entropy? So we'll calculate this. So when we have 4 plus 0, so how we'll calculate H? Minus 4 by 4 log 2 4 by 4 minus 0 by 4 log 2 0 by 4. This will bring to 1. What is this? Log 1? 0. Plus 0, and then what is this? Infinity. This is minus infinity. So that's why it will be 0 plus 0. Good. So if you see entropy, if it's so it will be like this. So this portion has x0 x1 and this has a this has a x0 and this has a x1. So if you think about this function log x by log x, so this will be this two portion, it will be 0, and this will be the maximum where it is 0.5. So therefore this is going to be the average entropy, and this is going to be the information gain. So when we calculate the information gain for all 4 attributes, we are getting 0.2, 0.02, 0.04 and 0.1, and then therefore we choose the 0.2 is the maximum information gain, which is the outlook, and then we divide it with an outlook, and we got already one node. This node has a leaf node because it has only one sample, one type of sample. Then we no need to divide it. And then again we will be dividing the sunny and the rainy part, and we'll get this tree. Okay. Now we come back to our iris data set. When I continue to go for, yes. Yeah. So the target will be already all will be the categorical. Target is a classification. You are thinking the target will be all categorical. Target cannot be the continuous here for classification tree. But when your features are the continuous, then you have to find a breakpoint. Then your task is more. So you cannot break it in every all the attributes, but you can select one value as a threshold and check what is the going to be the information gain.
The only probability is to make the binary decision tree only? You can make a binary decision tree?
No, you can make more than that. Means you can find out, you can take the 2 threshold also. So depending, but this cart actually do the binary decision tree. Here in ID3, once you have selected one attributes, you cannot select that attributes anymore because you have make all possible division of that attributes. But according to the cart, you can select attributes any time, any number of times, one attributes. And first time you take a threshold and break it. Maybe later sometimes you take another threshold and break it. That is also possible. So that will be similar to having 3 break of the same attributes. But instead of doing in the same label, you can do in the different label. Okay?
Now what if we have 2 attributes the same?
2 attributes have? Same?
Gain.
Gain. Then you have to break it by random break. Yes. But the problem is, once you break it, if you go down and if you think that other attributes could have been better, but you cannot take it back. Once you break it, it is done. So that is why the decision tree is a greedy algorithm. Okay. So this is the decision tree I got when I run the decision tree algorithm on this iris data set with two features and the Gini as a impurity measure. And I did not put any restriction. The decision tree will be stopped only it has either one sample with the same, one sample means the pure class of that node. Every node here has a pure classes.
Like in iris data set, the features are numbers, right? So we can't just do like yes, no.
Yes, we cannot do, no, we will be doing yes, no. But there you,
The features are also numerical, so 0 to
yeah, features are numerical. That's why I said that in that case, you will be having some threshold. You have to decide which threshold, greater than threshold. Now here, not on for it was a 4 features, but everyone was in the continuous range. Then you have to take, maybe you have to grid search, like you have to fix arbitrary 10 threshold and check all the 10 threshold how it is given.
threshold will be same for the entire.
No, not need.
And to find the best threshold, we have to see all the thresholds possible in the interval.
That is infinite number.
Each of those
But there's going to be a range linked to this. So if we say the smallest unit we are taking, say 1 unit, the numbers are ranging from 1 to 10, say 1, 1.5, 2.5, 2.3, and so on till 10. So if we see a small number, say 0.51, so 0 to 0.5 and the rest, then 0 to 1, then the rest. We have to check it that.
Yes, you have to take it that way. The later versions is 0 to 0.5 and then rest, 0 to 1 and then rest, and 0 to 1.5 and then rest. So you have to check. So you can take your this grid 0.5, you can take this grid at 2.
Yeah.
so if you find like entropy gain for each of those.
Each of the things. Yes.
So what is the time of
Okay. So it will be depending on how many times you are. It does not depends on, okay. For any algorithm, we calculate the time complexity depending on the number of samples. Okay. So you will be here, it will be order of n only. Because the number of node, you don't know, it will be how much. So this h is not depending on your samples, the number of heights in the tree, number of times you are dividing. It's not depending on your number of samples have. So that's why it is in the order of n only.
irrespective if the feature are numerical or either way.
Yeah, for ID3, when you can only break for the categorical features one time, then also your maximum height and maximum number of break, that is also bounded. But for the other decision tree where it will be continuous, you don't know how many times you are breaking it, how many threshold you are taking, and how many times you are taking one attributes. But still, it does not depends on the number of sample. Okay. Any other questions at this point? Okay. Now, what do you think about this tree? This is a good tree I have made for classification of 3 classes. I did lots of work, no? So many branches I have found. It is too big. And what will be the problem with having it too big? Overfitting. Overfitting. Right. Very good. So this is the region will look like when I break this tree. So it is only one data point is coming. See, this is one strip, one data points comes. It is so complex region and that is not good. Because always our samples may be noisy and noise can come from different sources. Somebody has put a label wrongly. Somebody has calculated some features with some calibration. If when you measure some length, it will be either in meter, you can put some 0.25 meter. Somebody can measure this length in some Armstrong. So you are not calculating maybe in Armstrong in all the time. So it will be some error, some resolutions error. And sometimes when some part like if you are working on the biological data, when people are measuring the protein structure, then its protein structure is always they are vibrating in a solution, so we will not be able to get the exact positions. So there are lots of regions for which this noise comes, and that's why we should not put much weight on the exact specific values. So now I am showing you that 4 steps I have break the my data space. First is only have 3 region, and the second one it is having I think 1, 2, 3, 4, 5 region, and the third has 6 region, and the fourth has the lots of. And now if you can see, this is the classification accuracy and the tree heights. So the red one is the training accuracy. So whenever we are increasing the tree heights, the training accuracy will be increasing, but the test accuracy after that point will be decreasing. So how to then select this height of the tree? It will be by the cross validation. You know cross validation. So what are the stopping criteria we can find for with the help of the cross validation is, one is if the entropy of a node leaf goes below some threshold, then we'll be stop breaking that node. This is pure enough for us. If a node has 9 samples from class 1, 1 sample from class 2, then maybe it is enough for us to get a class label. And we can have otherwise if the number of data points below some threshold. Or the third option is if the information gain is below some threshold. So we are not having much information gain by breaking the node, we are stopping. Now this threshold you have to fix with help of cross validations. What should be your thresholds? Okay, there is another thing that is called pruning. So tree prune, we can do the prune of a tree. So there is a difference between stopping early and pruning. So one thing is you just stop early and you will not make the full tree. And pruning is you make the full tree. Now you start deleting your tree. Delete one break or one subtree and check whether your total entropy of that tree or the leaves are increasing or decreasing. If it is not increasing, then you stop, you do it. And if you are saying that no, after this, if you remove this break, my entropy is increasing, my impurity is increasing, we will not delete that subnodes or that break. So here, so this one, if you see that this has a Gini 4.4, 4.5, this has a Gini 4.3 or you can take 4.4, this has a Gini 0 and this has a Gini 3.8. So on total in an average this has a almost same number of things. Maybe we can take it is almost 4.4 is the average Gini for this tree. And when we got this one, so there you can see already it has few, you are not able to see, I think it is some 6, some 0.5, some I think 0.8, somewhere 0.5, and if you calculate the whole Gini, it will be a little more than 0.4. And therefore, we can prune this subtree, we can remove maybe this subtree, and then we can remove maybe this one, and we can one by one remove these breaks, and we can make it shorter. We'll be making it short if this average Gini is not increasing. If it is increasing, that means that tree is performing not good. So this was our unpruned tree, and when we prune it, backwardly we delete the branches, then we'll be getting it pruned. So you can think about it that whether if you are getting, so how to do it by the, how to prune it with the help of cross validation is that you prune, you first classify your validation data set with the full tree, and now delete a branch, again classify your validation data set with the deleted tree, with the smaller tree, and you check the what is the result or the accuracy on the validation set. If the validation set, the accuracy increase, then you keep deleting. We'll end this decision tree here, but knowing the advantages and disadvantages of these trees. So one advantage, maybe you can tell us what is, tell me that what are the advantages for decision tree. Whether it is better than the yesterday with what we learned, the logistic regressions. Can you compare anybody? Structure is non-linear. Okay, and also one more advantage that it is very simple, and it will give you some intuition where you are breaking. What is the classification, interpretation of these classes in terms of the features, and also it will give you which features are more important to decide over this class. So now, like you have used maybe Amazon, you have used Amazon, Flipkart, those things. So how do you search something? Maybe you want to buy a phone. How do you do? In the first node, you go, you break, there are few breaks. So whether you want to find the cloth or electronics or furniture, then you go there in the electronics. And then from the electronics, then also you can go, either it is TV, phone and other things. Then when you are in the phone, then you can also search whether how many, what is the criteria you want in the phone. It is a smartphone, or it has a camera, or it is from some brand. So this tree structure are always there when we do our human search. It is always better for us. We can understand better. So these things actually reflect in this detail. So that's why this actually mirror the human decision. It is simple and it is easy to explain. It is easy to display graphically. And if here we have only 3-4 feature. You think about, you have thousands feature. And you got a linear function over this 1000 feature, and you are saying this is my classifier, you will make no sense out of it. But there you know that when it is a decision tree, then first node is breaking on some one feature. And then if you go a little deeper, maybe you will get 3 more features. So now you know among these thousands features, these 3 features are more important for us. So this can give you some qualitative predictors without need any creating dummy variable. For us in the logistic regression, we create the labels 0, 1. We'll be seeing for support vector machine it will be 1, -1, 1. But for here it is not required. We can use the category itself. But trees are not a very good performer with respect to the other classifier. They are poor performer. But how to make it more performing better way is that we'll be making lots of trees like a forest, and then take the average over those trees. So I think you have some session on these aggregations of the models, and the random forest will be explained there. Okay, we are not covering this here. Now it's time for your questions if you have any doubts. Okay. Yes. So, okay, I'll tell you only a few intuitions among this making many decision trees. You can randomly select some subset of your feature. So if you have 1000 feature, you randomly select 100 feature and then find the best among them for one tree. Now you are making the tree on those features. Again, for another tree, you randomly pick another 100 features and make another tree. So now your best feature may be different.
Features or training points?
Okay, you can do selects on the feature, you can selects on the training point, both. Both you can do. Even he raised a good point that if you don't want to break your feature, you just break your training points. So if you have in maybe 1,000 or 10,000 training points, you take only 1,000 among them and calculate your break depending on that sample. And for the next tree, you choose another set of samples and then calculate your best attributes on that sample. Maybe in that case also it will be different.
We are able to decide which test we have to do, then how can we say that the tree are not good at prediction?
Why I am saying that trees are not good for the predictions? Okay, because we don't go much deeper most of the time, and we can give a crude boundary, that's rectangular bound. We are restricted. We can give only the rectangular boundaries. Now, for an example, I'll show you. So, this is your data sets, two things. How I'll be breaking it? The tree. So you will be maybe having some division here, and then you'll be having maybe some division here, and then you'll be having maybe some division here. It is also the similarly for these things here, like that, no? But if you think about it, that maybe the information gain will be not much for each break, then sometimes when we are putting the threshold will be not dividing it also, maybe this will not be here. Okay, so in that case we are restricted that will be all the divisions will be parallel to our axis. We cannot build such a nice classifier here. That is one region that sometimes trees do not perform very well. And also when if you have thousands of the features and you will only selecting one by one, how deep you can grow? At a decision tree do not grow much over the tens height. It is not preferable, because the decision tree, the beauty of the decision tree in his interpretation. So you keep it small so that it will be interpretable. So then you can make a decision tree only taking the information from the 10 features. You cannot use the other features. So maybe you are losing something for that. That is answer your things. Good. Thank you very much.